Welcome to Pomodoro Joe for Saturday, June 3rd, 2023. Today we're doing LeetCode problem 1376, time needed to inform all employees. This is a medium problem. A company has n employees with a unique ID for each employee from 0 to n-1. The head of the company is the one with the head ID. Each employee has one direct manager given in the manager array, where manager index I is the direct manager of the ith employee. Manager head ID will equal -1. Also, it is guaranteed that the subordination relationship have a tree structure. The head of the company wants to inform all the company employees of an urgent piece of news. He will inform his direct subordinates, and they will inform their subordinates, and so on until all the employees know about the urgent news. The ith employee needs inform time index I minutes to inform all of his direct subordinates, i.e. after inform time index I minutes, all his direct subordinates can start spreading the news. Return the number of minutes needed to inform all the employees about the urgent news. Okay, and then we have some examples showing the tree relationship, and we have a bunch of constraints. Okay. Let's put 25 minutes on the Pomodoro timer and we will get started. So my immediate thought for this one is having a tree structure. We could do something like a depth first search or a breadth first search. We basically need to go down to all the leaf nodes to find out which leaf node took the longest to inform. Another thing we could do though is just a purely recursive function. And you know me, I like recursive, so we're going recursive with this one. So we will have some result. We'll set it equal to 0 to start, and we will return the result at the end. Okay, so before I write the recursive function, how would we go about doing this? Well, every employee needs to be informed. So if we just knew every employee's inform time, or how long it took to inform that employee, we could find the maximum inform time for all the employees, and that will be our result. Okay, so that means if we had some function that given the employee ID would return their inform time, then we could just calculate all the inform times for all the employees and find the maximum. So let's have some function here. So let's call it inform time, or time to inform. There we go. And it will take the employee ID. So I'll just call this ID. For now, we'll just pass, but that'll be our recursive function. Then out here, let's see, we'll need to go through every employee. So for each employee ID, so ID in range of n, because we know all the employee IDs are from 0 to n-1, then we'll just call this time to inform. So I'll call this time, and that equals time to inform this employee. And if this time is better, or if this time is longer than our current result, then our result equals this time. Let's do this way. If result equals time, time is greater than result. Else, it'll be result. That's just my quick way of doing a max calculation. Now back to our recursive function. Okay, so for this one, we'll need to know how long it takes to inform this employee. And it looks like we can find their manager, we can find the inform time, but the inform time is not how long it takes to inform this employee directly. This inform time is how long it takes the manager to inform their employee. So let's see, what is this again? The ith employee needs inform time I minutes to inform all of his direct subordinates. So the ith employee is the manager in this case, and they need the inform time to inform their workers, their managees. Okay, so I think what we want to do here is find this employee's manager, then find out that employee's manager's inform time. So we'll call this manager ID. And that will equal manager of this ID. Then we can get the manager's inform time. So let's see, it will take the manager's inform time to inform us, plus however long it took for our manager's manager to inform our manager. So that's going to be, we'll return this inform time for our manager ID. So that's how long it takes our manager to inform us, plus how long it took their manager to inform them. If only we had a function that would return the amount of time it takes to inform an employee given their ID. Oh wait, we do. It's this function. So we'll call a recursive function here. Inform, let's see, time to inform. It looks like I did a lowercase when I went to the uppercase. There we go. Time to inform our manager. Okay, so we'll find our manager. We'll find out how long it takes our manager to inform us, and then how long it took their manager to inform them, and that'll be our inform time. Now at some point, because this is a recursive function, we need a base case, and we don't have that right now. So what is the base case? The base case is when we work our way all the way back to the head honcho, the big cheese, the main squeeze, or maybe not that one, but the head boss. When we get to our head boss, they don't need any inform time. They're the ones making this decision or informing everybody from the very start. So let's see if the manager ID is equal to the head ID, then we can just return 0. It didn't take them any time to get informed because they're the ones informing everybody from the start. And I think that should do it. I think we're actually done. So we have our recursive function. We'll figure out how long it takes this employee to be informed based on how long it took their manager to be informed. And that will work its way all the way up to the head ID. Down here, we'll just go through every single employee, find out how long it took them to be informed, and the longest one is our result. Now one thing, this might take a long time, so let's add caching now. This is where I ran into a recursion depth exceeded problem. Turns out I was comparing the manager ID to the wrong value. I shouldn't be comparing it to the head ID. I should compare it to -1. Oh, that's the reason. All right. If we get a manager ID equal to -1, so if we get to the head manager, so what I should have been checking is this ID. If this ID were the head ID, then we return 0. Okay. This is a very Python-specific error that I was getting. I was getting to the case where we were returning an index of -1. So our manager ID was -1. So the inform time at -1 in Python is a legitimate inform time. It just takes the last value in this array. Any other language, it would have crashed. Okay, so that was my problem. My apologies. But I think we got it. So let's go forward and see what we get. And we pass, and we do really well actually. We beat 90% for runtime and 5% for memory. We could do better in memory. Let's go back and do our DP solution just so we can say we didn't cheat. So back to our DP solution, we have our default dictionary. It will take an int because that will be the key in this inform, in this time to inform. So we just say if ID is in our DP, we can just return DP at this ID. Otherwise, any other place where we return, so we go here, DP for ID equals 0. Now we still use ID and not manager ID because this is the input value as our key. And then down here, we do need to say DP at this ID is equal to our return value, and then we do need to return our DP at this ID. So this is essentially doing the same thing that the cache decorator does, but we're doing it on our own. So maybe it's a little bit more legit, I don't know. Still works. Let's see if it changes our runtime at all. And it does. We take a small hit. We're at 88% for runtime and 5% for memory. So caching is still better. Not too surprising. So I'm sticking with the cache. All right. What else could we do to make this faster? I like our 90%. I'm almost tempted just to leave it there. Let's see. Well, we could do our if statement up here. So if our ID is equal to so if our ID is equal to the head ID, then we'll return 0. This is the same thing basically that this is doing, but it might save us one recursion. So that might be a little bit faster, and a couple lines of code parsing. So that's going to save us a little bit there. Okay, see if this helps. Still works. Let's see if we can do any better than our 90%. And we actually take a big hit. Well, not a big hit. We take a little hit. 89% for runtime, 5% for memory. Didn't really save us anything. Okay, well, I think that's about all the tricks I have up my sleeve. I think you got this one? Yeah, you got this. All right, check this one out. Again, this is LeetCode problem 1376. It's a fun one. It should be pretty fast. Look how short this code is. So yeah, check it out. All right, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.